Okay, happy Tuesday. Here we go. How to wire. We're going to talk about a lot of information in this, like a lot of stuff. I'm going to try to go through it so I keep it under that 20 to 30-minute range. I put down, if this was actually in the classroom, get some paper. You don't really want to know what we're covering today. So here we go. We're going to talk about outlets and switches. We're going to talk about the different types of boxes that are available to put those in. We're continuing, obviously, in our learning of wiring in the house. We're going to talk about knowing what size wire there's all different sizes of wire from real small wire like what you use in your earbuds to all the way up to stuff that's huge. We're going to talk about the color coding because what we use in a house is different than what's used in your car or vehicle. Also because those are AC and DC, and there's a whole. We're not going to get into that, but just they're different. And then we're going to actually talk about wiring up an outlet and a switch, which will continue on as we go on this week. So, outlet consideration. Your home's going to need outlets. You need a place to plug in your phone, your hair dryer, your, you know, coffee pot. During construction, you got to kind of have some foresight into like, hey, I'm going to build a bedroom. Where will the bed most likely be in the bedroom? Do I want an outlet next to the bed? Yeah, because you're probably going to plug in your phone at night. And that's a modern consideration. Back in 1980, that was nobody's like, hey, I got to plug in my phone. No, but you had an alarm clock in the 80s and probably still have a light of some type. So it's having that foresight as you are building to figure out how many outlets you need. Uh, One of the things I always talk about is the room I'm in right now, our front little dining room. When we first got here, the walls that you see behind me, it was wood paneling. Like they painted it white and the paint was peeling off on now. So first thing McMullen did was he tore down all that. Uh, and all the old wiring, since it's exposed, I took it out and I rewired it. And if you look in this little room, I mean, the room is maybe we're about 8 by I think 12. It's not a really big little room, more of a nook. There is one, two, three, four, five, 6 outlets on 2 separate breakers. Why? Why? There's no need like for that many. But here's the deal. I knew at some point we're going to host Thanksgiving or a birthday party or whatever holiday it may be. And what does every family member bring over? A crock pot. And what always happens during family gatherings? 16 cords and a power strip all plugged into outlets, and then it's, we tripped the breaker again. Not me. Uh, the second year I think we were in our house, we hosted Thanksgiving. And sure enough, everybody comes with their crock pots. And I put 2 tables up in here and just plug them into an outlet. Oh, we're gonna blow the breaker. Oh, you got a power strip? That's not gonna do anything. No, you don't need one. Just plug it right in. Never blew a breaker because I had that foresight. I know they're like, McMullen, you're ridiculous. Have the foresight. So outlet boxes, that thing that we're actually gonna put the outlet in. It has to be in a box. You can't just put the outlet in the wall. There's 2 types. There's metal boxes and plastic boxes. Metal boxes were really common all the way up in a house, all the way up until 70s or 80s, and plastic started coming along. Metal boxes are still very common in commercial settings, but not as much in a house anymore. McMullen, it's a metal box with electricity. That's not. It doesn't ever electricity does not ever make contact with the box, and you ground out the box so that in the event that somehow it does, you're protected. There's a metal box. Notice this is probably for an industrial application or a commercial application because it has these things that look like nickels. They can be punched out. You take a screwdriver and just literally, they can be knocked out. And then you can run conduit, wire clamps, whatever it may be. You're not going to see those in a house. I actually do have some metal boxes in my house, not these. It's a different style. But again, they were common in older homes. Plastic boxes. They're really common nowadays, and they're so cheap. 30s, like, yeah, They're cheaper than metal boxes. They're really easy to install, and they're like 50 cents a piece, 30 cents a piece. If you buy in bulk, for a new construction build, they're even cheaper. Some downsides of them, they're made of plastic. If you miss with your hammer, you can break them. I have had that. Uh, there's no chance of shorting out terminals. Like, in other words, your wire ends, like something comes undone because you didn't do what you were supposed to. And a wire touches the side of the box, it's not going to short. It's plastic. There's two different types. And while you can go to Menards, and there is a, I should be yawning. It's 9 o'clock in the morning. I shouldn't be yawning. If you go to Menards, basically the way it works is if you see plastic gray boxes, more than likely they're for outdoor applications where you can actually seal them with glue and so forth for your conduit. That way, when it's outside, if it does rain, snow, whatever, they don't get wet, and then you really have a problem. Blue is going to be for indoor. Now, there is a company that makes like a grayish white indoor box. Yeah. So this is I call it the afterthought box. Notice it has these little tabs or wings up at the very top. The idea with this one is that you already have your walls up and you went, oh, I should have put an outlet there. Cut your square or rectangular hole, run your wire up, run the wire into the back of the box. Notice the box has clamps. These things only open so the wire can come through. And then if you try to pull the wire back out, it pinches it. And then these little wings up at the top, when you start turning the screw, they pop up and they hold it, or it holds the box up against the drywall. So these are kind of your afterthought boxes. There's a very common, that's a 2-gang box. But again, notice there's already nails that come with it. And it's hard to see in this picture. I wonder if next picture. Nope. There's normally these little tabs right here that just stick up. So that way, when you do new construction, you put it up against your 2x4 or 2x6 stud, and you make it so that it sticks out just far enough so that those tabs hit the outside of the board. And that way, when you go to put drywall up, the box actually sticks a ½ inch out from the 2x6 or 2x4 walls. That way, when you put the drywall up, it's perfectly flush with the outside of the drywall. And again, these are cheap. Outlet spacing. Here is the rules right now. And yeah, hallways, gotta have an outlet every 10 foot. And here's the catch. It's not actually every 10 foot. It has to be so that and this is the rule for all these, so that anywhere you're standing, you're within 10 feet of an outlet. The idea being it's for a vacuum cord or whatever. Usable spaces is every 6 foot. So that doesn't mean you have to go 6 foot outlet, 6 foot outlet. That means that technically you're spacing them 12 feet apart, because if I stand in the middle of that 12-foot section, I'm 6 foot from either outlet. So that's something you got to keep in mind. It's not every 6 foot. It's that you have to be within 6 foot of an outlet. So usable spaces, living, basically everything but a closet, a kitchen, or a bath or hallway. Everything else is considered usable. Bedrooms, living rooms, all that. Kitchen counters within 4 feet. There's also some other exceptions on that one. We have to have GCI breakers or outlets, which we'll talk about on Thursday. And then baths, again, every 4 foot. I have to be within 4 foot of the working area. Obviously, if you have a big giant shower, they're not going to be like, wait, if you're in that shower, there's no outlet. Like, no, working area. In other words, at the vanity. And so those are actual rules, and they are enforced. Like, I've had the electrical inspector in, they look at it and make sure that they can see too. Like, there's, they know that the demand for electricity is only going to keep growing. These are what they say are rules. Outlet spacing, follow those rules. Believe it or not, there is no rules on how high up or how low on the wall your outlet has to be. The common rule, they call it hammer high. So however tall your hammer is that you're using to put these in, most people just use that as a gauge. 12 to 14 inches. That's pretty common height. There are some rules, and you can see right there, plan out your house first. I talk about the crock pot buffet thing. There are some rules for like the Americans with Disabilities that if you build a handicap accessible house, the outlets have to be, at different heights and so forth. So depending on what you're building for, keep that in mind too. Switches. They come in all different types. We're gonna talk about that on Thursday. It used to just be this goes on and off, and now it dims and timers. We're going to talk about all that. Wall switches should be about 48-ish inches off the wall. If you're building a new house, go with that rule. If you're building or remodeling like we did, our outlets are a little bit lower than that. I want to say ours are measuring at 42. And I'm like, well, I could put them up to 48. I put them at 42 because you know what? It's going to be weird. Like your muscle memory going into a room and just clicking on the light. Yeah, I wanted it to be the same. You can see there 42 or 6 inches above the countertop for, kitchens, utility rooms, bathrooms, all that. Telephone outlets, don't have to worry about that. Those are dead. Thermostats, bedlit, all that kind of stuff. They put stuff in there, and those are recommended. Wire runs. In other words, how do we get a wire from one box to another, all the way back to our breaker? You got to drill into the wall, like the actual 2x4 studs, the 2x6s. You're going to drill typically a 3/4 inch hole, and they're not going to be pretty. You want a drill bit that goes the fastest, ugliest hole, because if you have a beautiful hole, yeah, it's nice, but it takes time to get those kind of holes. So I have this awesome auger bit I bought. Irwin makes it. It has a spiral on top, so it actually pulls itself in, and it has 3 razor sharp flutes. I can drill through a 2x6 and I'm not probably under 5 seconds. It's all, and that's just with a standard drill. I mean, it's 1, 2, 3, 4, 5. You're like, cool. You're limited to the number of wires that can run through your wall through one hole, and also you're limited on how many holes you can have, how big the holes can be, because you don't want to make Swiss cheese out of joists or floor joists or anything like that, because then you weaken your structure. Uh, Typically, it is the 1/3 rule. So, in other words, if I have a 2x10, no more than 1/3 of that can have, the hole can only be 1/3 the size of its height. So, roughly 3 inches. And then, it has to be so far apart from other ones. Check current codes if you go to build because they're always changing. Uh, a 3/4 inch hole, you're pretty safe with any size structure, 2x4 walls, 2x6 walls. The biggest thing is that you want to put it in the very center of the 2x4. So, you have that 3.5 inches width. You want it in the very center because if you're too far to the front, you risk having nails from the drywall or whatever you do, picture frames, going into the wire, and then you have a real problem. And vice versa. On the outside of the house, you don't want sheathing nails and so forth. So you want it right in the middle. If for some reason you drill your hole a little bit farther off, or there's any risk at all of a nail possibly hitting the wire, they make these little metal nailer plates. They're just a little tiny plate with 2 teeth on it, and you put it, if this is my 2x4 and I'm running the wire through right here, you put the plate on the outside. So that way, let's say down the road, you go to pick a picture frame. That little metal plate that's inside behind your drywall that's protecting that stud, you go to put in your drill or you try to hammer and you're like, I can't get through. Yeah, you hit one of those plates. Thankfully, you put it there because otherwise it would have been really bad. Wire selection. This is what I'm going to tell you. Look at your local codes and what they recommend. Go up to Menards in their little book section. They have the quick reference book on codes. For the most part, this is not always the case, but as far as I know right now, current code is bathrooms and kitchens must be 20 amp services for outlets. All of our other living areas, 15 amp. And then for your lights, 15 amp as well. This is where it kind of gets a little like, okay, wire size for running your lights and wire size for running your outlets, even though both are going to be on a 15 amp breaker, your lights are never going to pull 15 amps. I mean, you're going to have the like Frankensteining your lights kind of deal. But you're going to use 2 different gauge wires. The bigger the wire, the bigger the gauge, the more electricity it can carry, the more amperage or wattage it can, the bigger the pipe. So here's an example. Most of what you have in your house is 12-2, 12-2 in the outlet wall or in the walls and so forth. It'll handle 20 amps. Remember, it can always handle less. You can put less amperage. You can use 12 gauge wire on a 15 amp circuit. And 14 gauge, probably my mother calling. 14 gauge wire is going to be used for your lights. Now you can use it in the wall. I'm right. It is my mother. I'm curious what's going on. Um, you can use it in the wall, the 14 gauge, but that's minimum. I've always just ran 12-2. I can handle 20 amps or 15 amps. And for my actual bathroom, the 20 amp service, the longer your wire run too, there's so many variables. I actually ran 10 gauge wire, and the electrical inspector actually looked at me and goes, "Why'd you run 10 gauge wire?" And I'm thinking, "Oh no, I'm gonna fail." I said, "Well, it's pushing that 100-foot mark away from the breaker." And he's like, "You know, I can't say anything bad about it." And I'm like, "Okay, I didn't fail. That's good." He goes, "But I guess you earned an A plus, or at least a B plus." I'm like, "Huh?" He goes, "You need to think about this. What is the minimum grade to pass a class? It's a D minus. So this is the bare minimums. In other words, bare minimum to be safe in the house is a 12 gauge wire for 20 amp services. I went to a 10 gauge wire, can easily handle 20 amps, but again, I'm just trying to pass. Passing, the electrical inspection was a 12 gauge wire for 20 amp service. I did a little bit more, so I earned a B plus, is what he said. He goes, "There, you can go with the bigger wire; it doesn't hurt." He goes, "But most people, to save money and just pass, are going to use the bare minimum, because why are you going to spend a little bit more?" I'm like, "Yeah, I just didn't want to take a chance." He goes, "No, you did fine." But I liked his analogy. Uh, Nice guy, by the way. And here's some more things about your voltage and your amperage rating. We're not going to talk about it. Here's what you need to know. For almost every outlet in your house, 12-2. 12-2 will carry 20 amps and 15 amps. And why do we call it 12-2? It's the number of wires, not including the ground. There's really actually 3 wires inside that Romex. One's going to be a bare copper wire. That's our ground. And there's going to be 2 other wires. Hey, look at there. One's black, one's white. Our black is our hot, or our positive. Uh, you touch that, you're getting a zap. Now, the neutral and the ground should not carry load. Those are both negatives. And I know you're like, well, why is there a double negative? Both are grounds. Well, we're going to talk about that. This is a typical piece of Romex. You have the outside pointing at the screen. You can't see me pointing at the screen. You have the outside plastic, or it's like a really malleable plastic. Inside paper, still, there's paper sheathing protecting each wire from itself. On top of that, each wire is individually coated too with a plasticky rubber. Why paper? Isn't that like flammable? Yeah, sure. So is plastic. Most of the wire in my house in the older parts is paper sheet. It doesn't even have the plastic. The insides have the plastic, but the outside is paper sheet. Paper is an insulator. It's a great insulator. It doesn't conduct electricity. I'm doing a lesson, pumpkin butts. Set it there. I'll put it downstairs in the dress-up tote. Here's what you need to know. Our black wire is our hot wire. It's going to carry all the current. If it's hot, meaning like energized, you touch it, it's not going to be good. White is neutral. It's a negative. It's not going to carry any current. Be aware, though, just because that's supposed to be the rule doesn't mean it always happens. There's been times where you got straight current going through the neutral, and yeah, don't take chances. Again, like we talked about in day 1, shut off the power. And then that bare copper wire is our ground. Now, keep in mind that bare copper wire has only been around since like the 1960s. They started putting it in. And here's how it works. I'm vacuuming. And all of a sudden, I suck up the cord or a rug, and the motor on the vacuum starts to short out. Rather than me getting electrocuted by some chance, straight current goes through that ground, that additional bare copper wire, and back into the actual earth, not me. Remember, path of least resistance. That electricity just wants to get down to earth. That's all it wants. It wants to go to bare earth. That copper wire is a lot more conductive than me. Therefore, it saves my life. Also, I put down there, if your house gets struck by lightning, that's a massive amount of electricity hitting your house, but that ground helps. You're still going to have damage. Somebody that I'm friends with actually had their neighbor's house in Gaines, Michigan burned down across the street from a lightning strike this past summer. They actually said they were asleep. The dad worked, whatever shift at GM, heard this momentous crash, and literally saw electricity shoot out of outlets in his bedroom, and he just like was in a daze, didn't realize what had happened. And he said he saw literally like electrical current from static in the room after the fact. He thought it was a dream, and then next thing you know, fire started and they lost their entire house. Um, what are the chances of this? 2 weeks later, my buddies that lives over there that had that happen to his neighbor, his pole barn got struck by lightning. So I mean, it's not the same place technically, but still too close to comfort. I told him, I said, you guys like doing, like dark rituals or something, like bringing the wrath of something? That's scary. His barn was fine, but it actually blew out a wooden panel on the wall. It like just literally blew it out, and there was burn marks on it. So I don't understand why we don't do more home lightning protection in the United States. If you look back at, look at all the old barns in, around your neighborhood, they all had lightning rods. Our forefathers knew like that lightning stuff is nothing to mess with. I've never seen a lightning rod on a modern house ever. They do have them. So wire selection, we've already talked about that. You can look through this if you want right now. Remember, if we're going to have 220 volts, they'll actually be two hot, so two blacks, but technically one's red. But just to let you know. And then how do we connect all this? There's different ways. We can use wire nuts. There's an example. They got some heat shrink tubing. That's our car, electrics. We're not going to use it. Wire nuts, if you want to combine, like, hey, we got two neutrals, we got to combine. You can wire nut it. And then we're not going to talk about this because I want to actually show you in a video. I'm going to make a video of how to wire. But here's what I do want you to know. As we go into this, your black wire will always go to the brass screw. So hot always goes to brass. White will always go to silver, your neutral. And then the ground will always go to a green screw on the outlet. McMahon, my outlets don't have a ground screw. They're really old. Okay. If you have a metal box, take that ground wire and screw it into the metal box. If not, we'll cross that bridge when we get there. But at some point, you should be able to ground it out. Or just buy a new outlet. They're cheap too. They're like 60 cents. They're really cheap. They're just a basic outlet. But remember, black goes to brass, white goes to silver, green goes to ground. That is the rule no matter what. And there's some little things we're going to talk about in a minute or on the next lesson. There's different types of switch. We're not going to get into this today. Yeah, how to have it where one switch turns on the light and if you go to the other, it turns it off and vice versa. Jumper wires. It's not too bad. We're not doing that. No assignment today. We just wanted to run through the basics of outlets and wire gauges, just the basics. And again, at the end of the day, if you have any questions, do your research. Call somebody that knows what they're doing. Get a code book. There's some of those like, Stanley home guides to wiring and stuff like that you can look through. Educate yourself. Don't just guess. It's electricity. It can hurt you and kill you. That's all I got. Simple video today. Take care. Be safe. And we'll see you Thursday. Shut it off.